Alright, so this is what we're building today. This is the HoverBot Nano. And I'm going to try and give you guys a pretty complete build tutorial. So here's a quick rundown of all the components we'll need for our build. We've got the guard and the frame itself. These are carbon fiber. We've got these Delrin laser cut little guard links that connect the two together. And the kits actually come with 12 total, so you have some spares in case you do snap. 4 of these HoverBot 1103 motors. 4 6-amp ESCs. These ones are 1 to 2S compatible. A receiver. This is a This is a Lemon RX Diversity satellite receiver. FPV camera. This is a VM275T all-in-one, 25 milliwatts. 3D printed camera mount, the Pico BLX, and then this here's a little surface mount or a through hole JST-PH battery connector, and it will actually go directly onto the Pico, and it works perfectly with these JST-PH batteries. You'll need some needle nose pliers, snips, tweezers, an X-Acto knife, and you get old trusty soldering iron, as well as something to clean it and some solder. And then it will also be useful to have some CA, super glue, and double stick tape. So these little Delrin parts here that are laser cut are what make the entire design really possible. You can see they have little hooks in them. So to start off, insert that inside hook like this. And then you'll get this outside frame hook lined up. And it's possible to insert it with your fingers, but it's easier if you take your pliers and just clip it in like that. Repeat that with all 4 corners first. You want to be careful that everything's lined up correctly before you apply any kind of pressure. And use that to get it all aligned, and then just go in right at the tip with your pliers. Alright, that's good to go. So now for each of these outer points, you're just going to seat it down as far as you can with your fingers. There's another hook right there that holds onto the carbon, and also this entire piece is bent inwards, which will make sure that that hook is kept in contact. There's also a bit of a friction fit here, so you're going to need to use your pliers again. Alright, so you want your pliers just like this, attached on the frame, and then you want to use really careful pressure and nice and slowly guide that down into place. This is definitely one of the hardest joints to make on the frame, so don't try and rush it, and don't be too upset if you need to try again on one of the spares. So just real slowly. Alright, and that's all there is to it. This entire design only weighs 11.4 grams. It's actually really impressively stiff when it's attached together with the frame and the card. And then the other cool bit is that because the carbon parts are stiff and the plastic parts are just slightly flexible, they kind of act as they can flex together to absorb shock in an impact. I don't know if you can see that. Right now we're just going to go back and do the same for the Pico and just tin all the pads on it. And now for fitment reasons, we're going to go ahead and just get rid of this Spectrum satellite port here. Alright. Alright, so the quickest way to get these ESCs done is to pre-cut and tin the lengths of wire to the right length. Here it's about like between 2 and 2.5 centimeters, and then you can just solder them on all at once. Okay, so now each of the motors has had the leads trimmed down to about 1 centimeter in length. That's a little bit longer than it has to be, but it'll give us a little bit of extra working room in case we break one of the leads and need to reattach it to the ESCs. So next we're going to have to go ahead and tin these leads. So now you can see that you want to confirm that the tin has actually covered has gotten rid of that magnet. Right, so we're using these neoprene vibration isolation grommets here, washers. So go ahead and add 4 of those onto your standoffs. I don't know what you look here. Get it down on there. But there it is. Now we're just adding double stick tape to the underside of the ESCs here.
Do you know where the laundry basket, the white laundry basket is?
So now we're just going to take these, twist them up, and place. Alright, so I forgot to hit record for attaching the other motors, but it's pretty simple. Just watch. People keep mentioning it. Oh, responses. On the 1103 thread. No responses for the questions.
What do you guys want to eat though?
I like their shrimp shumai.
Shumai, okay.
Adam? How are you building right now? The pork.
Maybe. I'll get some more stuff. How hungry are you guys?
I could eat food a lot. keep getting smaller. You can see that we've fed the antenna wires up through these little holes here. Now, originally they were designed to be large enough to fit antenna tubes, but it turns out the tubes that I had on hand were just too large to fit. So what I'm doing here is just adding a little bit of heat shrink in there, which will be enough to protect to essentially stop the antennas from bending down into the props. And then let's go and just, the nylon here can melt pretty easily, so do be quick with the flame. Focus. Here's what we recommend to mount the batteries: is just feed a rubber band through like that, and then do the same on the other side. With that, the build is really complete, so let's just power it up and make sure everything works. It's a pretty good sign right there. You can see the nylon print here lets the LEDs kind of bleed through it color-wise, which is pretty nice. These VM275T cameras have a little green LED on the front, which is pretty nice. And of course you can kind of see the channel there at the back. And we're pretty much ready to fly, besides changing some config entries in Betaflight. Alright, 41. If you're really careful with the build, you can probably make it as light as 40 grams. Alright, talking propellers. These propellers installed right now are the kind of Ladybird style pre-drilled 56mm propellers, and they'll actually give you the best performance. They'll give you the best efficiency and are the lightest weight that you can get, plus it's nice that you don't have to cut them or anything. We've also got, so these here are DYS's 2-inch tri-blades, and we need to do a little bit more testing with them, but they offer pretty good performance at the expense of just a little bit of added weight and lost efficiency. And then actually my current favorite props at the moment are these HQ prop 3030s that have been cut down to size, just because they're still pretty efficient, but they've got this massive amount of surface area, which means that they're really quiet because they don't have to spin very fast to make this thing hover. So I'm a big fan of these cut down HQ props. And speaking of cutting props, this right here is a little 3D printed prop cutter that I made. I'll be uploading the files for it to Thingiverse in a couple minutes. It just uses a pretty standard nail cutter and a pin, and it's really quite easy to use. You just throw your prop on, snip, and that's it. That's all there is to it. So if you do want to experiment with cutting down other propellers, you can go ahead and make one of these for yourself for like $5, and I think it's well worth it. So there you have it. Just go ahead and post any questions that you may have in the comments, and I'll do my best to answer everybody's questions. Thanks for watching.